Hello and welcome to the last video in our discussion on time series analysis working with Python. So now a little bit of assumptions going into this video. So I assume that you've been through my other videos on time series, specifically the video on time series decomposition, because if you have not been through that aspect, if you've not been through that video, you're not going to be able to make it through this one because we are going to start where that video left off. So let me quickly remind you where that video left off. So in the previous video, we discussed time series decomposition. We took a signal that came from airport passengers over time spanning from 2009 to 2012. We decomposed it into the four components of level, trend, seasonality, and noise. And this is exactly where I'm starting today. So now if you're picking up where we left off, we are using the airline passengers update file that is available for you on Canvas. If you happen to just find your way over to this video looking for some help with time series and regression, welcome, welcome. Unfortunately, this video is specifically focused towards students that are in class with me. However, you can probably follow along with similar data sets. If you were to go out on Kaggle and just look for airline data, you could probably follow along and make this work. So the more the merrier. Welcome. Hopefully you gain something from this. So what we need to do is we're going to take the components that we created previously in the prior video, right? So in the prior video, we used the multiplicative model to do a seasonal decompose, and we called that components, right? So that broke this into the four components here. So what we're going to do is we're going to add those four components in to our existing data frame, right? So remember, we have a data frame called df, and in that data frame, we have gone through and we have replaced the index, which is the default index of just numbers, right, starting at 0, with the actual months that go along with the corresponding airport passengers. So that's what you see here. So let's do it actually a little bit different. Like so. I'll make it a little bit nicer for you. There we go. So we have replaced the default index, which is just numbers starting at 0, with the months that go into our time series like so. Okay, so that's where we start. So where we're going to start is we're going to add seasonality and trend as actual columns inside this data frame. So I'm going to go df seasonality, and that is going to equal our component dot seasonal. Now I'm able to do that because I'm using that seasonal decompose feature of stats model. And if you don't know what that library is, that's the library we imported in the previous video in order to make this work. I'll take a second and show it to you. So in the prior video on decomposition, we talked about stats model right here. And we pulled in specifically the time series analysis, seasonal decomposition aspect of that library. That's what I'm working with now. So the reason I'm able to use that is because that was part of that library. Okay, if you have not pulled that in, you definitely need that in order to do what I just did. So the next thing I'm going to need to do is I'm going to add trend as well, and we'll do trend with a capital T. And we'll take our component dot trend, like so, if I could spell trend right. And the last thing is, if you just want to see it, we can look at the head and you can see what it looks like. Well, probably need to hit a return in there. And there you have it. So let's talk about what you're seeing here. So you're seeing trend as not a number. So what if I looked at it a little bit more? So you're seeing trend as not a number, which is okay because some of these, you're not going to see a trend until you get to a certain point inside your data set, right? So it's got to go for a little bit, sort of like moving averages, before you actually go through and get a trend or see that trend. So what we're going to need to do next, before we do anything else, is we are going to want to remove those null value trend duplicate, or they're not duplicates. We just want to remove the null values because there's pretty much nothing that we do in class that likes null values. And we're going to use regression in just a minute. And with regression, obviously null values, that would be a no-no. Yep. All right. Want to make sure we are doing good on time. Okay. So what I'm going to do is I'm going to get rid of these. So I'm going to do a drop NA. So we'll go df drop NA, and we want that to stay. So we'll say in place equals true. And if you want to check that, we can look at the head again and they should be gone. And now we're looking good. Okay, perfect. So the next thing we're going to need to do is the part that's going to be unique or new to those that have never worked with time series analysis. We're going to take the month that's coming from this index over here. So we've got, this is July and this is August, September, and so on. We want to take the month and we're going to make the month a category. So for example, we're going to have a column right here and it's just going to say 7 because it's July and 8 because it's August and 9 because it's September. So we want to take this and plop it over there and just have the date, or excuse me, just the month, and that's it. So now in order to do that, we're going to use that date time feature that we used in the previous video to set the index. But this time when we do it, we're going to create a new column. So we're going to say df for our take up data frame. And inside our data frame, we'll say we want to take the month. I'm going to shorten it to cat for category. So month cat, so month category, and we're going to use that pd.date time, index. And from there, we're going to feed it our df index. So the actual index of the data frame we're working on, and we're going to tell it from that df index, which we set to time in the previous video, we want it to give us month. Now we'll look at the head again and we'll see if we got that working. Maybe I got a typo in there. I do, of course I do. Date time should not have a dot after index. There it is, and we got it. Perfect. So now here's what we did here. We've created really a categorical variable here. So basically any time series point that's in July is going to belong to the July category. And any time series that's part of August is going to belong to the August category. Now, even though we are saying it's categorical, it doesn't see it as categorical. So if I were to look at the data types, if I were to do D types and look at them, it's going to think that it is df.d types. It's going to think that it is an integer right here, and it is not an integer. Well, we don't want to treat it like an integer. We want to treat it as a category. So what I'm going to do is I'm going to convert this from an integer into a categorical variable. So here's how we do that. So we're going to do our df month cat. And we are going to say that that equals df month cat. And we're going to say as type, and we're going to change it to category. And we're actually going to spell out the word category like so. And if we want to test it, we can do dfd types. And let's see if we got it. We got it. Perfect. So now you're probably asking yourself, why would I want to go through and take this from an integer to an actual categorical variable like this, or data type? And the reason I'm doing that is because I want to use get dummies. So if you're not familiar with get dummies or the one-hot encoder or the label encoder that come from SKLearn, I've got videos on those too. So jump back in my 365 playlist and you'll see I've got an entire video on encoding, different methods of doing that, using get dummies, which is part of pandas, using the OHE, the one-hot encoder, which is part of SKLearn, or the label encoder, which is part of SKLearn. Now in this particular example, this is really simple, so we don't need to do anything crazy. We can simply use get dummies to make this work. So what I'm going to do is I'm going to do df equals pd.get underscore dummies, and I'm going to take my entire data frame, and when I do that, it's going to only look, and here we can give it the head. Actually, let's look at the whole thing. It's going to only find the categorical variables, and it's going to then one-hot encode those. So let's see what that did. So it took the month category column and it exploded it out based on every single value that was in there, right? And there were 12 different things because there's 12 different months. So the way this is going to work with our one-hot encoding is, for example, this is January. So any one of our data observations that is in January is going to be labeled with a 1. See it? 1. And anything in February is going to be a 1 here. Anything in March, so on and so forth. And you can actually see the pattern going down, right? See it? 1, 1, 1, 1, 1, 1, 1. You'll see it again. 1, 1, 1, 1, 1, 1, 1, as you go through that entire time series. So that's actually a pretty cool thing. Okay, that's actually pretty cool. So now this is the part where it starts to get a little tedious. But from this, we will be able to get some really cool stuff. So what I'm going to need to do, because I want to do linear regression, is I'm going to need to partition my data. And I'm going to partition it into training. And let's use a capital T for training and a capital V for validation. So I'm going to break it into training and validation data. Okay. So the training split that I'm going to use, I'm actually going to do it based on year. And my data ends in 2012. And notice that even though we did have all 12 months of 2012, 6 of them are cut off because there was no trend at the end. And that's okay. So when we removed the null values, those last 6 months went away because they were obviously missing trend. But we can still work with that. So I'm going to create a new variable called train. And within that, I'm going to pull just anything that happens before 2012. So I'm going to say train equals df, and then I'll say df dot index. And from there, we're going to say anything that is less than 2012, which is most of our data. So that's going to be our training split. And then our validation split is going to be the rest of 2012. So the only 6 months that we have. So we're going to do the same thing. We'll say df dot index, and we'll say greater than 2012. Now, if we did this right, theoretically, we'll be able to plot this in just a second. Wouldn't it help if I spelled index right the second time? See that? I left an E off. There we go. So let's take a look at that right here. So what are we going to do? Man, this space is driving me nuts. Let's take that away. Like so. Note to the wise here, and I tell my students this, in general, you should use comments all the time. It would make this video so much longer if I went through and typed comments for everything. But if we were really following good programming rules of thumb, I would be commenting everything in here so you were able to follow it. I just literally don't have time, or this video would be 45 minutes long with me typing everything out. So keep that in the back of your head. So now if you want to see what we just did, we should be able to plot this. So I'm going to create subplots. So we'll do subplot. And I'm going to plot my train and my validation. So I'm going to do plt.plot. And within that, I want to plot the passengers for my train and my validation. So I'm going to look at my train set first. And it's capital T. Train. And I'm going to take my passengers, airport passengers, that is. So we're going to plot that. And we're going to plot that against, or on the same plot with our validation data. Get out of there. Which is going to then be capital VAL. Still airport passengers. And we want to show that. So we'll do plt.show in just a second. plt.show. If we're lucky and we didn't spell anything wrong. Hey, look at that. We got something, right? So here is the signal that we've been working with. And here is our validation data that's coming off of it. So we've cut it off here, and then we've started that validation up for the last 6 months. So see it right there? There's going all the way up. Perfect. All right. So this is where we want to be. So now at this point, this is when we would go through and create our linear regression. Now, in order to do that, you're going to need the linear regression library. And I've already pulled that in from SKLearn, but I just want to show you what that's going to look like, right? So up at the top, and this is what we did in the decomposition video. We pulled all these other libraries in. I've set the default plot size as 8 by 8. And the one thing that you'll need to do is grab this linear regression model, which I've already pulled in. So from SKLearn linear model, we're going to take linear regression. Now, here's why we did what we did. So we created categories for each one of those point dates in time. And now we're going to use those categories as our actual trends, okay? As our actual trends. Now I'm going to cheat and I'm going to try to copy all these. And by doing this, if I'm lucky, I won't be able to do a ton, but I should be able to at least cut down a little bit on what I'm about to do. Because what I want is I want all of the seasonality, trend, and months 1 through 12 to all be predictors. So I'm going to cheat a little bit and copy these. If that doesn't work, though, we'll just retype it brute force method. So what I'm going to do is I'm going to create a variable called predictors, like so. And I'm simply going to give it a list of our predictors. That actually worked out better than I thought. Now, obviously, you know, this is not exactly right. So what am I going to have to do? I'm going to have to go in and add some things. So we'll do this. And we'll do this. Murphy's Law says I'm going to miss a comma or a parentheses in just a second, but let's hope that we do not. But this has got to be faster than me typing this whole thing out for you guys. So what I'm doing is I'm creating a list of what are going to be the predictors for my linear regression. I'm feeding it my trend, my seasonality, and all of the months that we just extrapolated from our data. That is how we're going to do this thing. So we're almost there, getting close. Sorry, if I can, I'll try to speed this up in the video edit here. No promises though, but I will try to speed this up in the video edit. Hey, we got something. Very good. So the next thing we're going to need to do is we're going to set our X and Y values, right? Because remember, with regression, you've got your X, your predictors, and your Y, your outcome, your target variable. So we're going to just call this X train. And we'll have another one called Y train. And what we'll do for X train, we'll say X train is going to be our train variable, or our train data frame that we used or created earlier, our train variable. And from that, we're going to take predictors that we just created. And then we're going to do the same thing for our Y value. So we'll take our train, and this time it's going to be airport passengers, like so. And hey, there we have it. So we've got our X train, we've got our Y train. So now, of course, we also need our X validation and our Y validation. So we're going to create that as well, X val. And we're going to have a Y val, like so. So from there, we're going to take our validation that we just created, and we're going to grab predictors again. And we're going to do the same for our target variable. So we'll say validation, and we want airport passengers, like so. Let's hope we spelled everything right. And we did not. Look at that. We called it airline passenger update. So that is, I don't know what that is. We'll just take that away. Try again. Airline passengers. Airport passengers is what it's called. Hey, nobody can get it right on the phone. Oh my goodness. All right, here we go. Let's just copy this like so. Let's just paste that right in there, like so, and see if we can get this right on the 11th time. Hey, there we go. For the life of me, apparently I cannot spell airport passengers. So the good news is at this point, it's pretty much linear regression, just like you always have. So there's not that much to it. What we would need to do is first go through and create an instance. So we'll say LR equals linear regression. And then we're going to fit the model. So we'll do linear regression dot fit, and we will fit it to our X train and our Y train. No problem. We're cruising right along now. So now that we've done this, so we've created our regression, but once we've done that, we need to evaluate it. We need to do something with it. We need to test it and see how good it is. So what we're going to want to do is we're going to create some estimates. We're going to use the model to do some predictions based on our validation set. So what I'm going to do is create a variable called estimates, and I'm going to call that model. We're going to say LR, so linear regression predict, and we are going to predict our X val data and see what we get. Capital V. Shame, shame, shame. Okay. So now, just like with regular linear regression. If you just want to see the estimates, there they are, and you can see them. But what we're going to do is we're going to keep working with it. And if you wanted to plot them, we could plot them as well. Like, so if you wanted to see them on top of what actually happened, we could visualize it and look at that. So how are we going to do that? How are we going to plot that and look at it? So if you want to see how the estimates work against the actual data, what we're going to do is start off with our subplots. Okay. From there, we're going to plot our training data first. So we'll do plt dot train, and we're going to look at our airport passengers, or plt dot plot. And we are going to look at our train. And let's see if I mess this up this time. Airport passengers. And then from there, we're going to do the same thing with our validation passengers and our validation prediction. So we'll do plt.plot. We're going to look at our validation airport passengers. And we are going to look at our plt.plot. There we go. We are going to look at our validation predictions. So we'll do val, and we'll do airport passengers. And we want not just airport passengers, we want validation predictions. You know what? I've actually skipped a step. So before I go through and actually validate this, you know what I'm going to need to do? I'm going to need to add something to that validation variable that I created before. So before I can go through and plot this entire thing, there's one other step that I need to do. So I need to take my validation predictions and put them into this validation set that I've got created here. So what I'm going to do is I'm going to take that val, or that subset, that data frame that I created, and I'm going to add val predictions. So validation predictions is just the name of the column that I'm adding. And I'm going to say that validation predictions inside that data frame is called estimates. So I knew I was forgetting something there. So let's try that. Yep, there we go. So now we'll be able to do this exact same line of code right here. And we're going to change airport to estimates, and I see there's a typo in here in just a minute I'm going to fix. So we're going to call this val predictions. Before I fix it, do you see the typo? I see it. I believe it to be right there. And we are going to plt.show. Let's see if we get lucky. There's always a typo in there somewhere. Will there be another one? There is not. Now, this is actually pretty good. So if you take a look at it, see the green line, see the orange line? So you're seeing the predictions on top of the actual data. Now, what we could do from here is we could actually go through and do our root mean square error if we wanted to. So I could actually go back, and I have already pulled in the root mean square error from SKLearn metrics. I did that in the previous video. I have pulled it in right there. So you can't just do it. You actually have to have mean square error pulled in. But if I'm interested in looking at it numerically, looking at the error, I can measure that. That is a quantifiable thing. So what I'll do is we'll do RMSE equals mean squared error, and we'll take our y-val and our estimates, and we will do squared equals false. And then we can print the results. Print RMSE. Y-val is Y, capital V. Got me again. Shame, shame, shame. And there you have it. Now, if you're interested in doing squared error, so I can take false to true, you can look at it there as well. All right, so there's our error. And in the end, there is regression using time series data. So with that, friends, that is the last of our video series for the semester. Hopefully you found that enjoyable. I know it was a lot, so I do apologize, but it was really cool. It's been a really good journey talking about time series and regression. So of course, if you have questions, give me a shout. You guys have my email address. You know how to send me messages online or on Canvas. And with that, my friends, hopefully this helps you out, and we will talk to you soon.